It says what? Okay, so stay with me right now. So now, min and max. Can we find the min and max once it's ordered?
Yes.
Yeah. Min and max, and your calculator can find all of this. So if we go to your calculator, and you do the same thing that you normally did, you go to calc, you say 1 for stat. I have the old calculator here, so I have to say L1. And remember where you found the median? Way at the bottom. If you scroll till you can't scroll anymore, there's your median, and you found your median before. These numbers are called your 5 summary numbers. The reason they are because they tell us where your quarters are. Your min, what is 6? Your max, 104. Don't we see that on our data set? Your quartile 1, 9. Your median, 16. Your quartile 3, 33. These are your 5 summary numbers. It separates your data into quartiles, into 25% zones, technically. At the median, you are physically at the 50% mark. Now, the reason they say on or above is because sometimes it has to include that value, and sometimes it falls smack in the middle, like on an even number. It'll fall smack in the middle. If I have an even number, there's an even number of data. My median now falls here at 4.5. Exactly 50% is here. Exactly 50% is here, because that median technically is not one of my numbers. So an on or about. Now, when you get to your calculator, these are the numbers that we're going to keep track of. And just so that you see us do it manually, and then we can do it in your calculator. So try these guys. I want you to put these in your calculator, and I want you to find me your 5 summary numbers. Find me your 5 summary numbers.
9. It only has L3 on the
And it's okay if you use L3 when you sort. You just say sort L3. Yeah. You can use any of the ones that you want. You just have to tell it which one you're going to use. So what's your min? What's your quartile 1? What's your median?
32.
Quartile 3?
40.5.
And what's your max?
46.
Okay. Notice your data's not that spread out. It's not that variable. Go up and look at your standard deviation for me. What's your standard? What's your SX?
8.0.
Okay. So there's a good amount of way. 8. Okay. So now, if we laid out this number line and we looked at where your data falls, you can tell approximately where, especially if you laid out your numbers, you can tell approximately where 25% is, 25% is, 25% is of your data. Basically, with your quartiles, we're going to use these to figure out your box and whisker graph in a short minute. And do you guys remember your box and whisker graphs?
No.
It's those little guys that follow a number line that look like this.
Yeah.
Like those?
No.
Yeah, it has your quartiles all set up. Okay, so for now, I just need you to make sure you go through and you can find all those pieces. Yes. Yes. Now, one thing that we have to talk about is an interquartile range. Your interquartile range is quarter 3 minus quarter 1.
And that's 42.
Not quarter 2. Quarter 2, well, this is your quarter 2, your median. But your interquartile range means between those little quarters on the quarter 1 and quarter 3. if I look for quarter one and quarter three, and I take the difference between quarter one and quarter three, how much of my data does that represent? Half. Good. If I'm from quarter one to quarter two, from quarter two to quarter three, isn't that 25, 25? Isn't that 50% of my data?
Yeah.
That's going to be this piece right here. This is going to be your interquartile range. So you're going to take your quarter three, and you're going to subtract your quarter one. And this is going to give you your interquartile range. Okay. That tells me how much of my numbers are going to lay right in between here, in between the quartile 1 and the quartile 3. That's the middle 50% of your data. Okay? The outliers, the other one, if we did the outlier for that one in the box and whisker, then again, you'd see your data's pretty much here, and your outlier all the way over there. Your box and whisker gives you a good look on your outlier as well. We're going to take this, and we're going to make a box and whisker out of this. This is all there really is to your box and whisker graph. Okay? Now, key to your box and whisker is your number line. It's kind of like your dot plot thing. Remember what your dot plot? You had to do the min to the max. Your min is 19, your max is 46. So say we go from 15 up to 50, and we go by 5s. It's like your number lines, just like your dot plot. When we did your dot plot. We plot these points above your number line. Don't sit them on your number line. So 19, just put dots there. 26.5, somewhere there. 32, somewhere here. 40.5, that came right up there. I don't know what that is. 40.5. And 46. The middle one makes the box. The middle dots make the box. The end dots are called where your whiskers go. Make the 5 dots. The middle ones, the middle 3 make a box. And connect them to your whiskers. Dots and whiskers. Now, 25% of your data sits here. 25% of your data sits here. 25% of your data sits there. Even though the box is bigger, 25% of your data sits there. So why, if this piece is 25 and this piece is 25, why is that box bigger? Not more data, still it's 25% of your data. The range of it, it's more spread out, isn't it? Your data is more spread out over that part. It still represents exactly 25% of your data. Okay? And when we separated this, you can see your pieces here. So you can kind of see where your range is going with that. So even though you might have a little whisker, your whisker might be like this. You might have a little whisker like this. This is still 25% of your data. It's just your data is all crunched in together. It probably is all the same number. Or like maybe 2 numbers in there, like put 6 of them. No. It's the range of each data set that's in there, the variability there. This one's more spread out than the rest. So it kind of gives you a feel for where your numbers exist. And each one of these represents a quarter of it. And your interquartile range from here to here represents the middle 50% of your data. Okay, everything is just divided into quarters. That's basically your box and whisker graph. Your median, which we know as the physical middle of your data, is your second quartile. Because below it is 50, above it is 50, right? So how much is 2 quarters worth? 50 cents, 50% of your data. Half below, half above. Your interquartile range is between the middle half. That's the box. This is the physical box of your box and whisker. So we can identify outliers now with this special formula. And if you take a look at this example, Here's your list of rules to find. You know how we said 104 is a definite outlier? Well, sometimes it's not as obvious when something is an outlier, especially if you didn't put it in order. You just notice that this number looks really high compared to the rest of them. And you might want to look at them sorted in order. But we have a series of things to figure out if it's a physical outlier or not. Once we put your data in order, and we look at it with a quartile 1 and a quartile 3, we find your interquartile range. We multiply that by 1.5. Now, here's your quartiles over here. Quartile 1, median, quartile 2, quartile 3. It's got to be out here somewhere to be an outlier, out here somewhere. So quartile 2 is not affected at all. Just quartile 1, quartile 3. We want to know how far away is it from my quartile 1? How far away is it from my quartile 3? So we take this product, the one we multiplied, your interquartile range times 1.4, so 1.5. We subtract it from your quartile 1. Any data then that is less than that, we're going to consider an outlier. It's going to put us out here somewhere. Anything less than that, outlier. We're giving it a little leeway. We do the same thing up here. But remember, now we're adding it here. We take this, we add that product here. Anything out here is considered an outlier. Okay? This is a nice way to determine if you have an outlier or not. Now the data with the 104, we will definitely see its outlier. So if you take a look at this data, here 104. We said your quartile 1 is 9, and your quartile 3 is 33. What's the difference between 33 and 9? 24. Okay, let's multiply 24 times 1.5. So it's 36. Okay, now, so we're going to say take 36 and subtract it from quartile 1. Quartile 1 is 9. If we subtract 36, we're in the negatives. Do we have anything less than that? No. Look how close together these were. Do you consider them as outliers? No. Now, we look to quartile 3. We say quartile 3 plus 36. So we say 33 plus 36. And we get 69. Any of my data pieces above 69 will be considered an outlier. Which data piece is above 69? 104. This guy is considered an outlier. Yeah, we eyeballed this one up. We knew that was an outlier. This was real obvious. But sometimes they're a little bit closer together and they're not as obvious until you apply this rule. You take your interquartile range times 1.5. You're going to subtract it from your quartile 1 because you want it to be outside of that area. And you're going to add it to your quartile 3. Quartile 2 is not affected by this. So we're going to try another one. Let's see if we have one that has it. Okay, let's look at this data. Your quartile 1, I thought we did quartile, but I guess not. 40.5 minus 26.5. This was 14. We're going to take your interquartile range times 1.5. Should give you 21. Now, we're going to take your quarter 1. We want it to be outside of quarter 1. How far outside of quarter 1? How far outside of quarter 3? Quartile 1 is 26.5. We're going to subtract 21. Anything 5.5 or less would be considered an outlier. Do we have 5.5 or less? No. Our lowest was 15, 19. Our minimum was 19. So we have no outliers on that side. How should I find the other side?
40.5.
40.5 plus 21. I am on this side, and I want to add this. So at 61.5 or higher. Do I have anybody at 61.5 or higher? No, so this data set had no outliers. And we could kind of see they all fall within the same area, right? The first quartile you subtracted because you want to see to the left, so you're going to subtract it. The third quartile you add it because you want to see past the right of it. It kind of does make sense when you think about it. If you're looking from the distance from here, there's your middle, there's your quarter one, there's your quarter three. Where can your outliers be? Out here or out here, right? Aren't those the outliers? So this has no effect on quartile 2. Quartile 1 says, well, if it's that way from me, shouldn't I subtract? Subtract the product of your IQR times 1.5. Quartile 3 says, oh, it should be more than this. Add the product of your interquartile range times 1.5. And that will be my cutoff for what's allowed. So that it's not considered an outlier. Anything past those end zones there are considered outliers. Okay. It's a nice little formula. It's a nice way to tell without having to guess to see where your data falls. Okay. So we found your interquartile range. We looked at that one. Try number 3. Here's a good one for you to try. On page 39. 39. This is your most powerful 50 women in the world of 2012. Remember their ages? So.
You want us to put all that in
This is meaningless.
All right. So instead of doing it, how would you find it then?
Like,
Put it in your L1, and then what? Okay, stat. Wonder stat. And then what do I find?
Good bottom line.
Your 5. Okay, then what? Pick all the numbers.
Then,
Subtract the
Quartile 3.
Good. Subtract quartile 3 minus quartile 1. This gives us our IQR.
And then add
What do we have to do first?
Multiply.
Multiply it by.
quartile.
Okay.
And then add and subtract.
Then you add and subtract. What of quartile 1 do I add it or subtract? I want to go the opposite way. I want to go down there. Subtract your IQR times 1.5. You want to add. So it makes sense, right? Anything to the left, I have to subtract to see where that was, where my cutoff is. Anything to the right of me, I have to add to see where my cutoff is. Make sense? Okay. I think we'll probably call it a day here.